So we had come up with a couple options on paper for how this could work. One of them involved grabbing point, what we called A, and getting that distance from point to point B, and using that as the scalar value of the vector that we've just made. So let's consider that. So we want the distance, so we get a number, which is a scalar. So if we type distance, it's fairly easy. One, compute the Euclidean distance between 2 points. Brilliant. This is exactly what we need. And again, the distance doesn't really matter what order we put it in there. We'll get out a number. If we hover, it's around a ½ meter. That makes sense in the scale of the problem that we're talking about, because we know that this vector that's shown on the screen right now is actually 1 meter. We know it's meters because it says it down here. Again, it doesn't matter the units so much. It matters that everything's defined relative to one another. Then the units will work out. So what do you do then in order to scale a vector, right? How can we scale a vector? Again, if you didn't have someone around, you would go to Grasshopper 3D and say apply vector scalar value, let's say, maybe something like that, which would be a good place to start. In this case, I will actually tell you that the best way of doing this is something called amplitude. And if we read what this does, this says set amplitude length of a vector. Again, all these components come with time, and again, you might not have said the word amplitude if you went and just searched and said scaling and blah, blah, blah. But with time it comes, and what does it ask you for? It asks you for a vector, which we know we have, and it asks you for an amplitude. So set an amplitude length of a vector. This is the perfect thing for us right now. And let's adjust what we've done previously. Instead of looking at the old vector here, let's look at the new vector and see if we got it right. And lo and behold, that looks, and when we've anchored it maybe at the wrong position, some would say, rather move its anchoring position over to here. Now we can almost see that basically if we move from our anchoring point to here, we'll end up right here. Let's see what happens. If we change our vector, oh yeah, we're getting closer now. We don't need this panel, and this was option 1. We said this would get us down to here. Let's just play, for instance, let's say, for instance, that we wanted to do option 2, which was the mouth, right? So let's bring the mouth forward, and we said effectively we wanted to get the amplitude relative to the distance, the length over 2. So type length. A lot of things come up, so you got to get clever at how you use it. I have a lot more than you potentially because I have third-party plugins, which you shouldn't have when you're starting off. You want to find the one that is for you from Grasshopper. It's just about geometry. You could come up here, and analysis is usually when it's kind of getting information from the data, in which case you can find the length here and measure the length of a curve. So we get the length. The length comes up to be about 1.2, makes sense in the scale of the problem. And now here's a little trick for you. If you want to do stuff with numbers without adding any new components, you can come in here, and the variable x over x is the variable that's coming out. So in this case, I know it says L at the output, but actually, if you just type in x over 2, what it will do is it will automatically divide the number that you're getting out by 2. Yeah? So that's a quick little trick. Otherwise, you could just say divide, division, and you could do that where you add in number 2 there. In this case, I would have divided it by 4. But hey, maybe that's what we want to do. So let's explore. We're here now, right? So that's the new point if I use option 1. That's the new point if I use option 2. And that's the new point if I use this sort of superfluous amount of divisions type of thing. So lots of options here. But let's try and tie it all together because we know that we're very close now. We can almost see the curve being formed. Option 5 was draw new mouth. All the way back at the beginning, we said our point was to draw a new mouth. Its start point would be the same starting point as the lines that these endpoints represent, right? So that's the start point. That's the end point. And the midpoint is going to be this point that we moved in step 4. Let's just group these up. And there you go. We now see a smile on the screen. I can clean up my script a bit here. And again, we can play with which mouth is the one we like the most. I don't know. It all looks about the same to me, especially if we hide this guy. Again, the point isn't make me the prettiest mouth in the world or make me one that's completely perfect. It's make the computer draw you a mouth. Again, the final version of this is meant to be a preview. Look at all of the sacrificial geometry. If I even turn on some of these guys, who we turned off previously, all of that, we've created so much in only our 4th version of the file, and really, at the end of it, we have to turn off the majority of it. But that's really the power of Grasshopper, is to be able to see all of those intermediate steps. I call this the DNA of your script. It's visually represented, and it's allowing you to be in greater control. The key about being a computational engineer in the built environment is most likely, at the time of this recording, you didn't get a degree, let's say, even a PhD is overkill, any degree in computer science. So a tool like Grasshopper, a tool like Dynamo, is meant to try and help you get into this space with techniques like this. Techniques like this will help you understand, again, what's going through the algorithm at every one given point. And you can actually step through the algorithm one by one if you can make it into geometry and actually see a preview of what's going on. This is an extremely useful technique and one that we will continue to use throughout this series. So in conclusion, that is file number 4, and you can see that just a small amount of changing of the data. All we did, we still had a curve, but now it was a linear curve rather than a 3-point arc type of curve. It not only did it make us have to change the algorithm that we used on a high level. So instead of a rotation, we had to use a different type of algorithm, which was a creation algorithm. Not only that, but we had to basically rethink completely a couple times what it actually meant, our create a new mouth algorithm, and how that actually feasibly works.